All right, welcome to the video on the algebra properties that we will be working with this year in algebra. Some of these you may have seen before, but some of them are going to be new to you. So we're going to start with the associative property. What I like to think about when I think about the associative property is when people associate together, right? So that's going to be a clue. When you see the associative property, you want to think associate. So the main idea is this, is you're going to move the parentheses around two different numbers, but the answer is the same. Okay, so you're going to move the parentheses. So let's look at a variable example. Let's say we have x plus y plus c, and that's equal to x plus y plus z. So if you think about it, first you're associating x and y together, and then it's moving and you're associating y and z. So that is your example of the associative property. And that's with addition. With multiplication, it's going to look very similar, but it has a different operation. So an example could be x times y times z, and that would be equal to x times y times z. It is important when you're doing the associative property that the order stays the same. See, in the addition, we have x plus y and z, and it stays the same. You're not moving the letters, the parentheses are moving to different numbers. All right, to see the numerical example, all we would do is just substitute numbers. So we can have 2 plus 3 plus 4, and that's equal to 2 plus 3 plus 4. Again, with multiplication, 2 times 3 times 4, so it looks very similar to addition, it's just a different operation. Instead of adding, we're multiplying. And that is 2 times 3 times 4. Okay? The associative property. Another thing sometimes, which might help you remember, are these two S's right here. Some teachers like to talk about slip, slide. So you're kind of slipping, sliding the parentheses. So that is the associative property. The next one we're going to look at is the commutative property. This one, your big hint is going to be right here in this CO. And that CO is going to stand for change order. So an example, or for the main idea, we're going to switch the order of the numbers. We're going to switch the order of the numbers. So let's look at a variable example. If we have x plus y, on the other side, we would have y plus x. Okay? And same thing with multiplication. X times y is going to be equal to y times x. We're switching or changing the order, CO. Another way I like to think about the commutative property is when you commute to school, or I commute to school for work, I'm going from one place to another. I'm switching places. So that's another way that helps to think about the commutative property. That you're switching the order of the numbers or the variables in this case. So if we look at it again, in numerical, we have 5 plus 7, and that is equal to 7 plus 5. Or if we have multiplication, we could have 6 times 9 is equal to 9 times 6. So we're just flipping that order. I do want to make note of this example right here. I'm going to put a little star. If we have 3 plus x plus 4, and then that is equal to 4 plus 3 plus x, some people might look at that and automatically assume because of the parentheses that that's the associative property, but it's actually not. That is the commutative property, because what's inside of those parentheses is staying the same. We're not changing the 3 and the x, we're just changing the order. The 4 is coming before the 3 and the x instead of after like it was in the first part of the equation. All right, so next up on here is the identity property. And when I hear identity property, I like to think of identical. Because what you start with is going to be with what you end with. So whatever value you begin with, Y-O-U, so the value that you begin with is what you end with. And what I mean by that is with addition, we're going to add 0, right? If you add 0, it doesn't change. And with multiplication, you're going to multiply by 1. You may also have heard additive identity or multiplicative identity. That's the same thing as we're talking about right now. So let's look at a little example of that. So if I had x plus 4 plus 0, I still have x plus 4. And in multiplication, if I have a b times 1, I'm still going to be left with a times b. So those identities, you're identical. What you start with and what you end with. So we started with x plus 4, we end with x plus 4. We started with ab, we end with ab. It doesn't change. Yes, the identity, it doesn't change. All right, now if we look at that with a numerical, we can go as simple as, let's just say we have 7 plus 0. Well, we all know 7 plus 0 is still 7. Likewise, if we want to say negative 12 times 1, well, negative 12 times 1 is negative 12. So those are examples of the identity property. Moving on, we next have the inverse property. And when you see the inverse property, you want to think opposite, okay? Because where we have addition, we're going to use the opposite operation. And where we have multiplication, we're going to use the opposite operation, which is division. So a number and its inverse yield the same answer. So a number and an example of that, if we look at a variable example, if we have x, well, we're going to do the opposite, negative x, right? We're going to have a positive x, and the opposite would be the negative x, or the inverse of x, positive x would be negative x. And that gives us, or leaves us with 0. Okay? With multiplication, if you have x divided by y, and the key word here when we're doing multiplication is reciprocal. Hold on, let me fix that for you guys. Okay, so the reciprocal of x over y, we're going to multiply by y over x. And what happens here is these will cancel each other out and you're left with 1, because you have x is here and y is here. Those cancel themselves out and you're left with 1. So that is the inverse property. It's the opposite. And if we look at it with numbers, we can say say you had 25 plus a negative 25, and we all know that's equal to 0. And if you have 4 over 3, you would multiply it by 3 over 4, and that would be equal to 1. So that right there is the inverse property. All right, moving right along. Next one we have the multiplicative property of 0. And this you've probably learned 1,000 times. That's just saying that anything times 0 is, we all know, 0. So if you have anything, A plus B plus C times 0, well, as soon as you see that times 0, you know that the answer is 0. Same thing numerically, if you have negative 10 times 0, well, that's equal to 0 also. So anything times 0 equals 0. All right, we got a few more left on the back. So we are going to look, and these are ones that most of these that we just went over, maybe you've seen before, maybe you haven't. Most of us should have seen it. But now we're going to get into some of the ones that we're going to start to see and use in algebra this year. So the first one is the distributive property. So when you think of distribute, you're thinking distributing papers out to students or to give something to somebody. So I'm going to put a little hint here. Distribute, to give out or share, might be a little hint that you could use right there. And the main idea is you're going to distribute the number on the outside of the parentheses to everyone inside. This distributive property. So an example of that would be, let's say we had A times B minus C. The distributive property says we are going to distribute, or we're going to give that A to both of those values that or both those variables in this case that are inside the parentheses. So we're going to have A times B, and then A times C, and we have a negative here, right? So it's going to be a negative AC. That's the distributive property. Same thing with numbers. If you have 4 and 2 plus 5, well, we're going to give that 4 to both of those terms. So 4 times 2 plus 4 times 5. Which I wrote it kind of separately. You can do it in 2 steps. 4 times 5, and then that could be equal, 4 times 2 is 8, and then 4 times 5 is 20, which would eventually be equal to 28. But the distributive property is actually this part right here where you're distributing that number to those values that are inside the parentheses. All right, so now we're looking at the reflexive property. So the reflexive property, you could think your reflection, okay? That's just saying that, think about it, if you look into the mirror, you on one side and what's in the mirror is the same thing, that's your reflection. So the left side is going to be equal to the right side. They're going to be the same thing. So you can have x equals x, y equals y, z equals z. The reflexive property. And a big clue in this, oh, we'll get to that next. Okay. So then if you want to see that in a numerical, it's just saying, okay, well, 4 is equal to 4, negative 2 equals negative 2, maybe 7 equals 7. And you will see the reflexive property used in geometry very often when you're doing proofs. So keep that in mind for next year. All right, so the symmetric property, that is going to be when you take a statement and you switch left and right values. So you're going to switch values from left to right and right to left. And that, to show you that, it's going to say, well, and a big, big thing with the symmetric property is you're going to be using, you're going to see if something, 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 then something, something, something. So let's look. An example would be if A equals X, then X equals A. Just like you could say, if X equals 4, well then 4 is equal to X. Okay? So the last one, the transitive property. Well, the last one, we're going to talk briefly about the closure property and properties of equality. The transitive property is going to be, you're always going to see if, and then. If, and then. So it's going to say, if something and something else equals something, then blank equals blank. That looks a little bit confusing, but if you see it with variables, and if I say if X equals Y and Y equals Z, well then, since they're both equal to Y, since X and Z are both equal to Y, well then X has to be equal to Z too. So if X is equal to Y and Y is equal to Z, well then X is equal to Z too. And if A is equal to 3 and B is equal to 3, well then A has to be equal to B. Okay? So these other two properties we're going to get into at a little bit of a later date. So since this video is already running about over 17 minutes, I'm going to talk about those briefly tomorrow. So if you have any questions, there will be a quiz that you have to take shortly after this. So thank you for watching. Take that quiz, and we will see you in a few days.